All right, guys, I have Unit 3, Lesson 2. We're going to do function notation. This is a 3.2 standard. You can recognize and use function notations. So function notation is completely new for you. What you did yesterday was review for lesson 1, but this is very new. So it looks kind of strange, and when I first introduced it, kids are like, oh my gosh, it looks so hard, but it's really not hard at all. It just looks hard, okay? It looks tricky. It looks like a weird way of writing a function. So let's start here with some info. So a function, like we learned yesterday, we talked about yesterday, reviewed, you learned it already, is a rule that takes an input. Remember our input? Does something to it, like does like some math to it, add, subtract, multiply, divide, and gives a corresponding, you got it, output. There is special notation called function notation that is used to represent the situation. If the function name is f, and the input is x, because normally our input is our x, then the unique corresponding output, we normally would say y, but function notation does this f of x, okay? Now notice how I said that, f of x. So the notation f of x is read out loud as f of x. You can evaluate functions from a given table, graph, or rule using this function notation. So it's just a very different way of writing like a y equals. So for example 1, it says the functions f of x and g of x. So they're telling you they're two separate functions, are represented numerically in a table. So use the table to evaluate the following. So okay, so let's look at the table for a minute. So they're saying like, here's my x's, here's my input. And this column, or this column here is the results, the y values for the f of x function. This is the y values, the third column here is the results for the g of x function. So if I said to you for A, f of 1, that means, okay, when x is equal to 1, okay, now just take your time with this. Listen to how I'm going to say this. That means that when x is 1, I'm going to come over here to the table where x is 1. And because I have an f of x and not a g of x, I'm going to go to this column. And I'm going to say, okay, well, if I know when x is 1, because it said f of 1, that's the input, the 1's the input. And I go to the f of x function, what's my output? And my output's -4. So this is when x is 1, y is -4. So that means f of 1, meaning when I put the 1 input into the f function, my result will be -4. So it's nothing more than a point, right? Coordinate point. Okay, let's try it again. Okay, this one says g of 2. So this one says, all right, I'm going to look at the g function, and my input is 2. So that means when x is equal to 2. So I come over to the table, and I go, okay, here's my x equals 2. But I need my g function, not my f. So I'm going to go to this column. When x is 2, I get the result of -6, sorry. -6. So that's when y is equal to -6. That's it. It's a fancy way of looking at it, like writing it, but it doesn't mean anything special. It just means this is the x value. So let's do it 2 more times, okay? Now this one has f of 0. You need to find f of 0 and add it to g of -2. Okay, so f of 0. That means when x equals 0. So I come to where x is 0, and I'm looking at the f function. So when x is 0, the output for f of x is -1. So let me erase this. So this is equal to -1 plus, okay, g of -2. Well, that means when g is when x is negative 2, I go to the g function and I get 0. And negative 1 plus 0 is negative 1. That's all. That's all they're talking about. So it looks fancy, but it's nothing big. Okay, so that was a table. Now I'm going to take you to a graph. And then last, the back page, we're going to work on equations. And I'm going to do only a couple on the back page, and then you're going to try some on the without me. Okay. So this one says g of negative 1. So remember, this means when x equals negative 1. So I'm going to go to the graph where x is negative 1, which is here, and I'm going to find where the function hits. And it hits right up here when x is 3. So that result is 3. So basically, I could say that this is a coordinate point, right? Negative 1, when x is negative 1, y is 3. So here's, for B, my coordinate point. When x is 4, what's y? So go to where x is 4, and oh, look at that. It's right on the x-axis. That results in 0. Okay. Try A for B, for graph B. Take a minute and find h of 3. H of 3. Take a minute. Usually. Okay. So you should have been here when x is 3, and you should give me negative 2 as your result. Okay. So now for B, it's a little bit different. It says find x when h of x. Now remember, this is kind of just like a fancy way of saying y equals. So they're saying when y equals 1, what's x? So I'm going to come up here to where y is 1. Okay, here's where y is 1. And I got to find where x is. But look at that. I've got 2 x values for that 1 y. So I could say h of negative 2 gives me 1, or h of 1 gives me 1. Either one of those will work. They're both correct. Okay? All right. All right, so how does this work when given a function rule? Okay, so we did it on a graph, or we looked at a table, we just looked it up on a graph. Now we're going to actually have a function rule, which is nothing more than an equation. So it says, for example, the function rule y equals 3x plus 4 is written as, okay, now remember, I just said it's kind of like just a fancy y. So instead of a y, we're replacing it with an f of x. Same rule. So we're reading it f of x equals 3x plus 4. But what does that mean? Well, it means that the function rule f takes x as the input. Okay, so whatever this number is, it goes in here for x. And it says it's going to multiply that number by 3 and add 4 to it. And the result is the output. So you're going to do, and I'm only going to do a couple of these. Like I'm going to actually leave a couple from each. Okay, so here's your first example 3, and it says, here's your function rule. F of x equals negative x plus or minus 15. Okay, so go to A here. It says f of 4. Well, remember, that means when x is equal to 4. So I'm going to say, okay, f of 4 really is equal to negative, remember, x is equal to 4. Replace that 4 with, or replace that x with a 4, minus 15. And then you just do the math. So negative parentheses 4 minus 15 is negative 4 minus 15 is negative 19. That's it. Okay. How about B? I'm going to come here. And I am going to replace all x's with negative 10. So a negative 10 with a parentheses and a negative outside, negative and negative make a positive. So 10 minus 15 is negative 5. So the coordinate point, basically, if I were to start graphing this, is when x is negative 10, y is negative 5. Okay? So I'm going to have you try C. So we're going to leave C for you. And then I look at 4 and I think, ooh, that's a biggie, right? Okay, so I got a g of x equals x squared plus 2x minus 1. So, and it says find the range when range given the domain. Okay, so that just means domain. Make a little table if you want. So I got when x is negative 4, when x is 0, and when x is 8. And I'm going to say, okay, well, I'm going to come over here to the function. And I'm going to replace all x's with negative 4 to start with. And I've got g of negative 4, and I'm going to do all the math over here, right? Do the negative 4. Just pop in your calculator. Don't put, the only part you're going to put in your calculator is that right-hand side of the equal sign, right? So you're not going to put in g of negative 4 in your calculator. Just put in parentheses negative 4 squared plus 2 parentheses negative 4 minus 1. You're going to pop all that in, and you're going to get 7. 7 goes there. And then you're going to do it again for 0. And then you're going to do it again for 8. And you're going to fill this out. You're going to finish this. You got this. But they're telling you, they give you the domain, so you're going to plug in the range to find the range. Okay, now 6 is a tad bit different. Okay, so it says find for f of x is equal to negative 8x plus 27, find x. Now you got to find x when f of x equals negative 13. So look, I'm going to replace this with a negative 13. So negative 13 equals negative 8x plus 27. Do the math. That's what you got to do. Minus the 27, I get negative 40 equals negative 8x, divide by negative 8, and that is 5 equals x. There's my solution. All right, so I got one more I'm going to show you, and then I'm going to have you try example 7 on your own. All right, so let's look at example 6 here. So now I got f of x and I've got h of x, okay? Two different functions, and it says f of 1. So I'm going to come here and I'm going to replace, you got it, all the x's with 1s. Okay? So that's 3. Then I got h of 3. And I'm going to replace all of the x's with 3. And I've got 9, negative 81, plus 6 times 3. I'm going to peek here because I already did it. And I got negative 63. Make sure my math is right. Yeah. Okay. Now, what I did was I did them separately, right? So I put that in, I put 1 in for the f function, 3 in for the h, and then it says, like, basically it's going to come back here and you're going to say, take those results and add them. So you're going to take 3 plus negative 63, right? And you're going to end up with negative 60 is the final answer, okay? Because they want you to get those two and then they want you to add them. That's it. For this one, you're going to find f of 5, and then it says find that answer and then multiply by 2. So you're going to do B, you're going to do 7, and you're going to make sure that you went back and filled in these guys right here for 4. Okay? All right, I'm out for today. So you have a good time doing the math. Make sure that you do the homework associated with lesson 2 in the homework packet. And if you have any questions, you know where to find me. Talk to you soon.